Welcome to This Explainer. Today, we're tackling something we all think we know, but probably don't know quite well enough, and that is fire safety. We're going to unpack the internationally recognized NIBOSH principles to see what's actually happening at a chemical level. Because, understanding these mechanics, it isn't just a boring compliance exercise. It's actually a fascinating look at how to genuinely save lives. It's all about taking those everyday objects around us and understanding their hidden potential so we're never ever caught off guard. Here is the quick roadmap for our explainer today. Number 1, the anatomy of fire. 2, the classes of fire. 3, your firefighting toolkit. 4, the pass method. And finally, 5, golden rules of safety. All right, let's jump right into section 1, the anatomy of fire, or the science of combustion. So when you really look at the NIBOSH framework, it's pretty wild to realize that fire isn't actually a thing. It's an event, right? It's a highly specific, rapid chemical reaction called combustion. It doesn't just spontaneously happen out of nowhere. For combustion to even occur, fuel has to combine rapidly with oxygen in the presence of sufficient heat, which then produces the heat, light, and flames that we associate with a blaze. Without all those exact conditions perfectly met, fire simply cannot exist. The absolute easiest way to map this out is the classic fire triangle. The first piece of the puzzle is heat. Think of a seemingly innocent frayed wire, welding sparks, or even just heavy friction on a factory floor. The second piece is fuel. This is literally anything that can burn. And in our workspaces, this isn't just the obvious stuff like paper or wood, it's the hidden fuels like cleaning chemicals, aerosol cans, or, that forgotten pile of cardboard sitting in the supply closet. And finally, the third element is oxygen. Now here's a detail that really puts things into perspective. Our normal everyday atmosphere already contains about 21% oxygen. So what does that mean for us? It means the third element of our triangle is almost always present. It's just hovering there, waiting for the fuel and heat to kick off the reaction. The environment is already perfectly primed for combustion long before a spark ever flies. Which leads us to a totally brilliant, elegantly simple strategy. If fire absolutely needs all three sides of the triangle to survive, stopping it isn't really about fighting the fire itself. It's about breaking the triangle. Starve the fuel, cool the heat, or smother the oxygen. If you cut just one of those sides, the whole reaction completely collapses. It's a beautifully logical way to approach what is otherwise a totally chaotic event. But wait, it gets even cooler. Modern fire science has actually upgraded this concept to the fire tetrahedron by adding a fourth element, the chemical chain reaction. What's mind-blowing about this is how certain tools, like dry powder extinguishers, actually work. They don't just smother the oxygen or cool the heat, they actually hack the fire at a molecular level. They release chemical agents that bind with combustion radicals to instantly break that chain reaction. It's basically microscopic warfare against the fire. Let's move right along to section 2, the classes of fire. This is where we learn to really know our enemy. Because here's the truth. Treating every fire exactly the same is a massive recipe for disaster. We have to match the tool to the chemistry of the threat. For everyday materials like wood and paper, those are your Class A fires. Water is great. But if you throw water on a Class B flammable liquid or a Class F cooking oil fire, it instantly flashes into steam. That creates a violent, explosive splash that spreads the burning fuel literally everywhere. We also have Class C flammable gases and Class D combustible metals like magnesium, which require highly specialized dry powders. And for electrical fires on live equipment, using water will conduct the electricity right back to you, which could be absolutely fatal. We have to use CO2 or dry powder to safely interrupt those. It's a really stark reminder that chemistry truly dictates our response. Okay, so now that we understand what we're up against, let's look at section 3, your firefighting toolkit, specifically looking at extinguisher types and their identifying colors. In a panic, you definitely don't have time to be reading the fine print on a metal canister, right? That's exactly why the universal color banding system is pure genius. Red is for water, cream is for foam, blue for dry powder, black for CO2, and yellow for wet chemicals. You can spot your tool from clear across the room. And here's a terrifying but super vital detail about that black banded CO2 extinguisher. The gas inside expands so incredibly fast that the discharge horn drops to freezing temperatures instantly, causing severe frostbite in seconds. You literally never want to touch that black horn while you're operating it. So we know the science, we know the classes, we have our tools. Let's hit section 4, the pass method, to understand how we actually take action safely. When the adrenaline hits and the alarms are absolutely blaring, complex instructions just go right out the window. That's exactly where the universal pass method comes in to anchor you. P is for pull. Pull the safety pin to unlock the lever. A is for aim, and this is huge. Aim at the base, where the fuel actually is, not at the dramatic flames dancing up top in the air. S is for squeeze. Squeeze the handle to release the agent. And finally, S for sweep. Sweep side to side, covering the entire base. It's simple muscle memory that kicks in exactly when you need it most.
And that brings us to our final and undeniably most critical section. Section 5, the golden rules of safety. This is all about knowing when to fight and when to flee.
Look, it's easy to want to play the hero and jump into action, but the NEBOSH guidelines emphasize a really important reality check here. Before fighting a fire, you need a mental green light across the board. You need to be officially trained, the fire has to still be small and contained, you must have the exact right extinguisher in your hand, your escape route behind you has to be completely clear, and the smoke cannot be blinding you. If even one of those is a no, it's a red light. It's time to go. If that mental checklist fails, or the fire is growing, your one and only job is evacuation. Stop what you're doing immediately. Raise the alarm to alert everyone else in the vicinity. Get out safely using the nearest unblocked exit. Call the emergency services from the outside and report directly to your assembly point. Sticking to this exact, predetermined sequence is what keeps a bad, uncontrollable situation from turning into an absolute tragedy.
I just want to pause right here for a second, because this is the absolute overarching philosophy behind everything we've explored today. Life is always more important than property. No building, no piece of equipment, and no inventory is ever worth your life or the life of a colleague. We've unpacked the combustion cycle, decoded the color systems, and walked through the pass method. But the biggest takeaway isn't just knowing these scientific facts in your head. It's having the spatial awareness to actually use them. So I want you to take a look around your workspace right now. Where's your nearest extinguisher? What color is its band? If a fire sparked right this very second, are you ready? Thanks so much for exploring this with me today, and stay safe out there.